Good morning, students. So, today we are going to discuss about the 2 mark solutions for the first 4 chapters. So, here are the questions for the 2 mark solutions. The first question is, express the following P by Q form where P and Q are the integers and Q not equals to 0. So the first subpart is x is equals to 0.6 bar. Now 0.6 bar can be written as 0.666 dot dot dot. So only one number, that is 6, is repeating itself. So we will multiply with 10. Since only one number is repeating, so we will multiply it with 10 on the both sides. So we will get 10x is equals to 6.6 bar, which implies 10x is equals to 6 plus, this can be written as 6 plus 0.6 bar, and 0.6 bar is nothing but x, so we can write 6 plus x. Now we will transpose the side of x, so we will get 10x minus x is equals to 6, which implies 9x is equals to 6. Subjecting x, we will get x is equals to 6 by 9, that is 2 by 3. So 2 by 3 is in the P by Q form and 3 is not equals to 0, so our Q is not equals to 0. Now subpart 2, where x is equals to 0.47 bar. 0.47 bar can be written as 0.4777 dot dot dot. Here you can see also only one number is repeating itself. Since only one number is repeating, we will multiply it with 10. So we will get 10x is equals to 4.7 bar. So 4.7 bar can be written as 4.3 plus 0.4777. So 4.3 plus 0.477 can be written as 4.3 plus x. That implies 9x is equals to 4.3, which implies x is equals to 43 by 90. Now 43 is a prime number, so we cannot divide it by 90, and you can see 43 by 90 is P by Q form where Q is equals to 90, which is not equals to 0. So this is how sums like this are done, and this is one of the most important sum in our first chapter. Second question is, write 5 rational number between 3 and 4. You can see 3 and 4 itself are rational numbers, and we have to find 5 such rational numbers between the two consecutive rational numbers. So since we have to find 5 rational numbers, so the denominator should be made equal to 5 plus 1. 5 plus 1. 5 plus 1 means 6. So we can write 3 equals to, in the numerator also we can write 3 into 6 by 6. Whatever we multiply in the numerator, the same thing we will multiply in the denominator. So it will give us 18 by 6. So you get 3 can be written as 18 by 6. Similarly, 4 can be written as 24 by 6, because we are going to multiply one more than the required number of rational numbers we have to find. Here we have to find 5 rational numbers, so one more than 5 is 6. So we will multiply the number 4 with numerator as well as in the denominator with 6. So we will get 24 by 6. So between 18 by 6 and 24 by 6, there are 5 different rational numbers. They are 19 by 6, 20 by 6, 21 by 6, 22 by 6 and 23 by 6. So these are the 5 rational numbers between the two given rational number 3 and 4. Now our third question. Find the 3 different irrational number between the rational number 5 by 7 and 9 by 11. So when we have to find 3 irrational numbers between rational numbers, so first we will find the decimal form of the rational number given. 5 by 7 can be written as 0.1744285. Again it will repeat itself, so it is given a bar. So we have to see whether the same sets of number is repeating. And 9 by 2 can be written as 9 by 11 can be written as 0.818181, so 0.81 bar. We know irrational numbers are non-terminating and non-recurring number. That means the division does not end and same sets of number do not repeat itself. So we have to write any three numbers between these two numbers or decimal expansion form. So they can be 0.7234596 dot dot dot, 0.742575 dot dot dot, and 0.7812395 dot dot dot. The choice of numbers between the two numbers in decimal form can be infinite. Only thing we have to remember that we have to write non-terminating and non-recurring decimal as it is an irrational number. It is only irrational number. Now question number 4. Verify whether the following are zeros of the polynomial indicated against them. So Px, first one is Px is equals to 3x square minus 1. So in place of x we are going to substitute by minus 1 by root 3. We will get minus 3 into minus 1 by root 3 whole square minus 1, that is 3 into 1 by 3 minus 1. 3 and 3 cancels each other off, so we get minus 1 plus 1, which is equals to 0. Again, in the same polynomial, we are going to substitute the value of x with 2 by root 3. So we will write x into 2 by root 3 whole square minus 1, which is equals to 3 into 4 by root 3 minus 1, which is equals to 3 and 3 cancels each other out. So we will get 4 minus 1, that is 3. So we have to indicate whether the given values of x are zeros of polynomial or not. So from the first value we can see that px becomes a 0. So we can write minus 1 by root 3 is a 0 of the polynomial, whereas 2 by root 3 is not the 0 of the polynomial. The subpart 2 we have px is equals to 2x plus 1. For x is equals to half, we have to see whether the given polynomial has its 0 or not. So in place of x, we are going to substitute 1 by 2. So we will write 2 into 1 by 2 plus 1. The 2 and the 2 cancels each other out. So we will get 1 plus 1, that is 2, which is not equals to 0. Since it is not equals to 0, so we cannot write it as the 0 of the polynomial. So our answer is hence 1 by 2 is not the 0 of the polynomial. We do not have the 0 of the polynomial for this polynomial px is equals to 2x plus 1. Now question number 5. Find a 0 of the polynomial in each of the following case. To find a 0 of the polynomial, we have to equate px to 0. So first subpart we have given px is equals to x minus 5. So we have to equate px to 0 to get the 0 of the polynomial. So in place of px we are going to write x minus 5 is equals to 0, which implies x is equals to 5. So 5 is the 0 of the polynomial px. Subpart 2 we have 3x minus 2 as a given polynomial. Here also we will put px is equals to 0, which implies 3x minus 2 is equals to 0. On subjecting x we will get 2 by 3. So 2 by 3 is the 0 of the polynomial. And the last question for today is Find the value of k if x is equals to 2, y is equals to 1 is a solution for the equation 2x plus 3y is equals to k. So we have a polynomial 2x plus 3y is equals to k. In place of x and y, we will substitute the value 2 and 1. And then we will find the value of k. So the solution will be x is equals to 2 and y is equals to 1 is a solution of 2x plus 3y is equals to k. So substituting the values, we will get 2 into 2 plus 3 into 1 equals to k, which implies 4 plus 3 is equals to 7 is equals to k. So the value of k is 7. So these are the 2 marks questions from the first 4 chapter of our NCERT book. I hope this tutorial is helpful for you. Thank you.